On this 2014 to 2018 GMC Sierra 1500 with the 5.3 gas engine, P0072 means the ambient air temperature sensor circuit is being seen low by the ECM. In plain language, the module may be interpreting the outside air temperature signal as hotter than it should be. The driver may see a service AC message, the system can use a default value, and the displayed outside temperature may not update the way you expect, because that display is filtered and usually changes while driving, not while parked. For this diagnosis, think in broad fault areas: the sensor behind the grille, the signal circuit, the low reference circuit, connector condition, and possible module side issues. The ambient air temperature sensor is monitored by the engine control module using a signal circuit and a low reference circuit. The module watches the voltage drop across the sensor. Cold air gives the sensor higher resistance, and warm air gives it lower resistance. The ECM converts that voltage into a temperature value and sends it to the display module. For P0072, the code sets when the ECM detects the sensor signal is more than 88 degrees Celsius or 190 degrees Fahrenheit. The monitor is gated by normal operating basics: ignition on, and the 12-volt battery voltage greater than or equal to 10.2 volts. Before going into pinpoint testing, start with the basic system checks and follow a structured diagnostic approach. With ignition on, or the vehicle in service mode, first look at whether P0072 or an ambient temperature companion code is currently set. If it is set, go into circuit and system testing. If it is not set, check for any other ECM or temperature-related codes. If other codes are present, check what they mean first. If there are no other codes, let the vehicle cool completely to ambient temperature before comparing scan data. Once the vehicle is fully cooled down, use actual ambient temperature as your reference. Verify the scan tool intake air temperature parameter is within 15 degrees Celsius, 27 degrees Fahrenheit, of actual ambient temperature. If it is not, follow the intake air temperature sensor diagnostic path instead. If it is within 15 degrees Celsius, 27 degrees Fahrenheit, then check the ECM ambient air temperature parameter. That value also needs to be within 15 degrees Celsius, 27 degrees Fahrenheit of actual ambient temperature. If it is not, continue into the ambient sensor circuit testing. If it is within range, the check is okay at that point. For circuit testing, turn ignition off, let all vehicle systems power down, and disconnect the harness connector at the B9 ambient air temperature sensor. Be patient here. It may take up to 2 minutes for every module to shut down. Test for less than 10 ohms between the low reference circuit terminal B, or terminal 2, and ground. If that reading is 10 ohms or greater, keep the ignition off, and disconnect the appropriate harness connector at the K20 engine control module. Then test the low reference circuit end-to-end for less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in that circuit. If it is less than 2 ohms, the diagnostic path calls for replacing the K20 engine control module. If the low reference to ground test was less than 10 ohms, turn ignition on and look at the ECM ambient air temperature parameter. With the sensor disconnected, it should read colder than -30 degrees Fahrenheit, -34 Celsius. If it reads -30 degrees Fahrenheit, -34 Celsius or warmer, turn ignition off. Disconnect the X1 harness connector at the K20 engine control module and test for infinite resistance between the signal circuit terminal A or terminal 1 and ground. If you have less than infinite resistance, repair the short to ground on the signal circuit. If the circuit tests at infinite resistance, the diagnostic path calls for replacing the K20 engine control module. If the scan tool reads colder than -30 degrees Fahrenheit, -34 degrees Celsius, install a 3-amp fused jumper wire between the signal circuit terminal A or terminal 1 and the low reference circuit terminal B or terminal 2. Now verify the scan tool ambient air temperature parameter reads warmer than 180 degrees Fahrenheit, 82 degrees Celsius. If it reads 180 degrees Fahrenheit, 82 degrees Celsius or colder, turn ignition off. Disconnect the X1 harness connector at the K20 engine control module. Then turn ignition on. Test for less than 1 volt between the signal circuit and ground. If the test shows 1 volt or greater, repair the short to voltage on the signal circuit. If it is less than 1 volt, turn ignition off and test the signal circuit end-to-end for less than 2 ohms. If that circuit is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, the diagnostic path calls for replacing the K20 engine control module. If the jumper test makes the SCAM tool read warmer than 180 degrees Fahrenheit, 82 Celsius, treat the connector terminals with dielectric grease, then reconnect the B9 ambient air temperature sensor. Reproduce the operating conditions that run the monitor, and verify P0072 does not reset. If the code or symptom is still not corrected, continue with testing of the B9 ambient air temperature sensor. If the code stays gone, that part of the path is okay. Also remember that when the ECM no longer detects the malfunction, the code can become history. For the component static test, place the B9 ambient air temperature sensor in a stable, temperature-controlled area for at least 10 minutes. Then measure resistance between the sensor signal terminal A, or terminal 1, and the low reference terminal B, or terminal 2. Compare that reading to the specified ambient air temperature sensor resistance information. That specification is required for the decision, so do not guess a resistance value. If the reading is not in the specified range, replace the B9 ambient air temperature sensor. If it is in the specified range, the component test is okay. After the repair is complete, verify the repair and confirm the code stays gone under the conditions that run the monitor. Keep verification separate from the circuit tests. First prove the low reference, then prove the signal circuit, then prove the sensor response. Bottom line, P0072 is handled by comparing believable temperature data, checking the 2-wire sensor circuit in order, and only condemning a component or module after the circuit tests support it. For more diagnostic training, visit stepdiagnostics.com.